We are going to continue doing lesson 3-2. When we did the notes, page 172. When we started the notes last week, I had you guys skip example 1. And so we are going to kind of pick up where we left off, and we're going to talk about example 1, how to write an equation. And then we're going to go over just a couple of kind of minor things that I think will be a little bit familiar because you guys have already kind of worked through this homework once. And so today's homework should be fairly simple. And if we can get through the notes in about 15 minutes, you should be able to get your homework done even before you leave class. Okay, that's my goal. But if not, you've got until Wednesday. I'm going to change the due date to Wednesday since you guys are going to USI tomorrow. Okay. All right. So example 1 is writing an equation based on a story problem. And it says that a 10,000 gallon swimming pool, so that's kind of one bit of information that you need to take note of. It's a 10,000 gallon swimming pool, needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool and into the tanker. How can you determine how long it will take to pump all of the water out of the tanker? So if you're now, and I've got it written right here. And the reason I have it written here is because in a minute, we're going to look at it from the vantage point of the pool. But for right now, we're looking at this as from the point of view of the truck or the tanker. So the water is going into the tanker, and we're going to write an equation to determine how long it's going to take for that tanker to get all the water in there. Okay, so a couple of things we need to know. First, we need to know that the tanker begins with 2,000 gallons in it, which means that's our what? If it begins with 2,000, that's our B. Very nice. The tanker begins with 2,000 gallons already in it. And you know to write an equation, right? We need an M and a B. That's our B. Okay. Now it also tells us right here that the hose or that the pump or whatever can pump 720 gallons in 1 hour. And that's your what? That's your M. Good. Because that's what's going to change every hour. And anything that changes per hour, per day, per whatever, that per is the important word there. Anything that changes per hour, that's going to be your M, because 1 hour, 720, 2 hours, another 720, 3 hours, and so on and so on and so on. So your M is 720. So with that information, we can write an equation, and our equation would be Y equals 720, because that's our M, right? That's our change, per hour, so times X, plus the 2,000 we already started with. And if we actually wanted to solve this, because it says right here, it says, how long will it take to pump all of the water into the tanker? Well, how much is all of the water? What's the total amount we would pump? How much? That's what we've already pumped. Lane? 10,000. It tells us right here that it's a 10,000 gallon swimming pool. So remember that the X stands for each hour that we're pumping. So the Y would stand for the total water. So we could actually write an equation. Total amount of water would be the 720 per X plus the 2,000 already pumped. We're not going to do it, but we could move the 2,000, divide by 720, and we could actually solve for X. And if you did this, you'd get, I think it's 11.1. So it would take a little over 11 hours to pump all of the water into the tanker. Now, I want you to notice that we're pumping water into the tanker. We started with 2,000 in the tanker. We're putting water into the tanker. So our slope was a positive because we're adding 270 gallons per hour into the tanker. Remember when we had an equation last week and it was you have a bank account and you withdraw $5 per week. That withdrawal was a negative slope because you're taking out of your balance. This was a positive slope because we're adding to the tanker every hour. So I want to actually also look at this from the vantage point of the pool. And that's what this problem is doing. It's the same information, but we're talking about it from a different point of view. Now we're looking at the pool, right? So the amount of water remaining in the pool at the very beginning of our story problem is what? How much is already gone and how much is left in our pool at the start of our story? 2,000 is gone. So that's from the point of view of the tanker, but from the pool's point of view, how much is still left in the pool at the beginning of our story? 8,000, right? Because we started with 10,000, 2,000 has already been pumped out. So notice our B changes here because we're beginning our story from the pool's point of view. We're beginning our story with 8,000 gallons in it. The amount of water pumped out each hour is still that 720, but the water is leaving the pool at a rate of 720 gallons per hour. So our slope, so our B is still going to be, our B this time is going to be 8,000 because that's what our pool is beginning with. And we're losing 720 gallons per hour. So our equation from the pool's point of view is y equals negative 720x because it's losing 720 gallons per hour plus the 8,000 it already has to get out of there. Make sense? So you have to really look at when you're writing an equation from a story problem, you have to ask yourself, I'm starting to lose it. You have to ask yourself, what vantage point are you looking at? Are you losing something every minute, every hour, every day, whatever, every week? Are you gaining something every minute, every hour, every week, whatever the time is, okay? If you're losing something like losing money in a bank account, losing water in a pool, whatever, then your slope's going to be negative. If you're gaining something every unit, then your slope's going to be positive. And then your B is just always, what do you begin the story with? Okay. All right. That covers writing equations from story problems. Now, something else I want to show you is that in your homework, they did something where they said, write an equation where distance, well, this would be gallons, where gallons is represented with a G and time is represented by a T. And if you wrote your equation, y equals 720x, they said it was wrong. Okay. And here's why. Here's the reason. This is our x-axis, right? It's always our x-axis. But in this case, they're wanting you to use t to stand in place of the x. So in your equation, instead of an x, they wanted you to write a t. Everything else stays the same. But the t stands in place of the x because in this particular story, the x-axis is time. And in this particular story, the y-axis, which here's our y-axis, it's always our y-axis. Here's our y in our equation. But in this particular problem, they want you to use a g to stand in place of the y. So it would be g equals 720t. I still want you to always think about it is in terms of y equals mx plus b, because that's generic. That will work for every single graph on the planet because you always have an x and a y axis. But sometimes they're going to ask you to rename your x and your y. And you just have to be able to know what goes in place of the x and what goes in place of the y. Okay. So I want to show you, this isn't in your workbook, but I still want to show you this. On our homework that you're going to do tonight, you're going to have one similar to that. And so I want to show you what it'll look like. So I'm going to just go up to this front page just so I can have blank space. Okay, so if you want to flip to this page, it's page 171, just to give you some blank space to work. It's number on your homework. Yeah, it's this one. It's going to be number 7 on your homework. So if you want to make yourself a little note, you're not going to necessarily have the exact same numbers. So I'm not going to work the math part of it, but I want to show you this. Okay. It says, here's your table. And it says that this is weeks. And it said this is the money in the account. I'm just going to put the money symbol. Okay. And then it asks you to write an equation for the money in her account, and it tells you M. So for money, we're going to use M. For the number of weeks, W. So they want you to use W for weeks. Well, we know, right, that this is our X and this is our Y. And I'm not going to do the math part of it. I want you to do the math part of it. Okay. So what I've done here is just kind of replicated. And I'm just going to make up numbers here. I'm not going to use the numbers in your graph. But let's just say it's 1, 2, and it's 10, 20. Okay. I'm just making up numbers here. So the first thing I'm going to do is I'm going to find my slope by looking at my change in Y over my change in X. Well, my Y's, in my case, and this is the example you're going to write down in your book to do number 7 on your homework. I go up 10 every time on my Y, and on my X, I go up 1 every time, right? So my slope is my change in Y over my change in X, or 10 over 1. So in my case, in this example, my slope would be 10, right? And so I'm going to put Y equals 10X, but I'm not going to input that into the computer because in this case, my Y is going to be an M because they want you to use me to use M for money. So I would put in my place of my Y, I'm going to put an M. My 10 is going to stay the 10 because that's my slope. But then my X, they want me to use in place of X. They want me to use a W. So in place of X, I'm going to put that W. They mean the exact same thing. It's still Y equals MX plus B, but you're just going to use an M and a W instead of a Y and an X. But in order to do that, you've got to be able to, in your head, know that the M is the Y, that the W is the X. How do you know that? Well, in a table, the X is always on top. The Y is always on bottom. If they give you the information on a graph, they would call the X-axis weeks or W, and they would call the Y-axis the money, right? And they would say that's the M. So if they give it to you in a graph, you've got to know which is the X and which is the Y-axis. If they give it to you in a table, you got to know that the X is on top, the Y is on bottom, okay? These are the same. This is what they're asking you to put into the computer, and they tell you to use M and W, or they might tell you to use D for distance and T for time. Make sense? Okay. The other thing I want to cover, this is all stuff we've already done. How to know if it is linear or nonlinear. I'm going to use this example. This is on page 174. Thank you. There we go. On page 174, I'm going to use this as an example of how you would do this. Okay. Wants to know if this is linear or not. Okay. First of all, is it a function? That's one question you can always answer. Is this one a function? Look at your X's, which they don't actually say X, but we know this top row is our X's. Any repeaters? No cheaters? So this is a function. Now we're going to decide, is it linear or nonlinear? Well, how do you do that? First, you look at your Y's. How do they change each time? They go down -50. That's right. Each time you can see a pattern. They go -50 each time. Okay, that's constant. So we're good so far. Now look at your X's. What do they do each time? They go up by 1 each time. That's constant. So could you say that your slope is your change in your change in Y over your change in X? Well, it's a constant change. Your Y's go down 50 each time, and your X's go up 1 each time. So your slope here would be -50. Make sense? It's a constant plus or minus. Okay? So this would be linear. It's linear because your change in Y over your change in X is constant. Could we graph this? Well, yeah, we can graph it. We could even write an equation. Y equals our X, right, which is -50. Our M, which is -50. Y equals MX. What's our B here? No. Remember, your B is when your X is 0. No. It's my beginning here. When my X is 0, that's my beginning. 300. My beginning is 300 in this particular case. So that means I would graph it beginning at 300. And I would go down because it's a negative 50. I would go down 50 and over 1, down 50 over 1, and so on and so on. And I would get a nice straight line. Okay. All right. What about when you've got one? We're going to go specific one I want to do here. Yeah, this one. We need to fill in some gaps. It tells us that the population of the ants doubles every 3 weeks. No, every 3 months. Sorry, every 3 months. So if it doubles from 22, what's this one going to be? 44. It's going to double again to 88. It's going to double again to 172. Is that right?
76.
Let's check it. 88 times 2 is 176. All right. Now I want to ask you this question. First of all, is this a function? Look at your X's. Any repeating X's? Nope. So is it a function? Yes, it's a function because you guys know this, each X has good exactly 1 Y. All right. Now, is it linear or nonlinear? That's question number 2. Why nonlinear? A lot of people would say this is constant because it's times 2 times 2 times 2. But when it's multiplying, that's not considered constant. Because if I graphed this, if I go over 3 and up 22, and then I go over 3 and up 88, I'm not going to get a straight line. For this to be considered linear, it has to be plus or minus only, not times. If it's times anything, it's definitely not linear. It's considered exponential because it gets bigger really fast. If I double 176, it gets a lot bigger really quickly. If I double that again, it gets bigger quickly. If you have a bank account, would you rather add $2 every week or double your amount every week? Right? Because if you just add $2 every week, you're going to get a constant increase of $2 every week. And that constant is linear. But if you double your amount every week, you're going to go from 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64. You just went up to $64. Whereas if you just got $2 more every 2 weeks, you'd only have 2, 4, 6, 8, $10. So see how it gets much bigger, much quicker? It's called exponential. It means it shoots up really quick. It's not a linear graph. So anytime you see a pattern of multiplication in your Y's, it's nonlinear, okay? And the reason for that is because your change in Y's is not constant. Even though it's a pattern, it's not an addition or subtraction pattern. It has to be an addition or subtraction pattern to be linear. And then it'll ask, what is it in a year? Well, you guys have already done this, but if this is 3 months, 3 months, 3 months, the next one we could put in here would be 12. And if it doubles, 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 we could double it again. And we could put 352 here. So we could answer the question that in a year, we would have 352 ants. And the way we do that is we just extend our table out one pattern, one box, and we follow the pattern. +3, +3, +3. That's our pattern for the X's. Double, double, double. That's our pattern for the Y's. Okay. So as far as the answer, it is non-linear. And you could say that the Y's are times 2. Okay. Yes. It is. It is. And you're going to have one very similar to this on tonight's homework. Okay. So that's why I wanted to make sure and cover it with you a second time. Okay. So you can tell whether or not it's a function and whether or not it's linear or nonlinear from a table, from a graph. From a table and a graph, you can write an equation if it's linear. Can I write a linear equation for this? Could I write a y equals mx plus b for this one? Can I write an m if I don't have a constant rate of change? No, because I can't do a change in y over change in x. So you can only write y equals mx plus b, that's a linear equation for a linear set of points. If your points aren't linear, then you can't even have an m, so you couldn't have an equation. Sound good? All right. You guys have a homework that is assigned on our Canvas homepage. If you go to our Canvas homepage, you'll notice that it is on today's date, 3-2. Notice you do not have to turn in any work paper. You still have to get an 80%. And if you have any questions, you can ask me, Miss Hain, or if you're at home, you can email me.